Okay, so today I want to talk to you about files. And specifically file I/O, which is input, output. I'm going to have to rush through the first part of this because we spent a little time talking about matrices, but I want to tell you a little bit about the architecture that's on the computer that you're using. Right, so your computer has a central processing unit, a CPU. Maybe I'll draw this. Sorry again, YouTube. These pictures must be awesome. Okay, so here is your pretend this is your computer somehow. Right, this is your the main motherboard of your computer. In your computer, you have something called the CPU, the central processing unit. And what the central processing unit does is perform all of the mathematical operations that your computer may need to do. Now, in order to do any type of computation, as you may have discovered, we need to be able to store things. Right? Store X, store Y, now add them together and store that somewhere else. So the CPU needs access to some type of memory. Well, things on a computer are very tiny. These are called microprocessors for a reason. If I put memory here, the memory here is going to be a lot easier and faster to access than if I put memory here maybe. And I'll explain to you what here and there means. Right, so here's a motherboard, here's a CPU. It has access to very fast memory called the cache. And there's levels of cache. So my first level here is level 2 cache, then level 3 cache, which is a little bit bigger. And then further away from the CPU is something that we call RAM, random access memory. Further up from RAM is something that we call the hard drive, the hard disk. And further on from the hard disk is something we call the cloud. Right? Cheap and plentiful, measured in petabytes. A petabyte is 1,000 terabytes, right? So this is a functionally infinite amount of storage that we have in the cloud. Moving one back, who has a computer? Redundant. What is the hard drive capacity of your computer? 512. So here we have 512 gigabytes. You must have a solid state device. Right, okay. So typically, right now, if your computer has an SSD, do you know what the difference between a solid state device is and a hard drive? I don't want to diverge too much, but suffice it to say, a solid state drive is a little bit more expensive than a hard drive, right? So you have half a terabyte of storage on your computer. People with non-SSDs, conventional hard drives, maybe have approximately a few terabytes of storage here, 1,000 gigabytes. I thought this would be impossible. My first computer had a 1 gigabyte hard drive on it, and I was thrilled, right? RAM, random access memory. This typically is measured in gigabytes. My computer has, I don't know, let's go back to this gentleman. 32. Wow. Whoa. Yeah, jeez. Big star on campus. So that gentleman has 32 gigabytes of RAM. And I'll tell you what my values are for these. I have 256 kilobytes of L2 cache and 4 megabytes of L3 cache, right? So fastest, smallest, most expensive. Second fastest, little bit larger, still very expensive. Larger, less expensive, but slower. More slow, but less expensive, bigger, and the biggest, right? So obviously, if you wanted your CPU to pull information from the internet and compute, that's going to take a while, right? If you want to load something from the L2 cache, that's measured in milliseconds, right? So you're going to learn a lot more about this in computer architecture if you take it. It's relevant. It's relevant to us already, right? Because when you launch Python, it's working in here, in the random access memory, for which you have normally not a lot, not if you're this gentleman, you have 32 gigabytes of RAM, but let's imagine you wanted to read in a movie, a really big one, 4K, 60 frames per second, 6 hours. It's not going to fit in RAM, right? So we have to now tell Python, look, at some point you may run out of this type of memory. We need to use the bigger memory that's one step up. It's going to be slower, it's going to be harder to access, but I don't know, unless you want 64 gigabytes of RAM, you're going to have to move, right? So we will teach you eventually. So my PhD is in scientific computing. That's really like taking a computer and using 100% of its resources to do a computation. So you're going to have to know about the computer architecture. If you ever want, because we haven't never given you a problem yet which your computer can't handle. Eventually, I want to be able to give you a problem which your computer can't handle, just so you can get an appreciation that computers aren't these like infinitely powerful, capable machines. It's very easy to come up with a problem where a computer is already useless, which is why you need to study math, which I would recommend. Okay, so I explained why files. We need files because I need a way to access memory that's higher up. Okay, so we're just going to do examples today. I'm going to create a file. And this file is going to be comprised of what a new line, wonderful new line, hello world new line. So let's draft up that file. Okay, so I'm going to move to my desktop here. I am going to create a file. What did I call it? Hello.txt. I'm going to fill it with something. What did I say? What a. So what a. Then I'm going to hit return. Oh. What a wonderful line, hello world, period. Whoops. I hate Vim. Okay, so I'm going to show you one command that you don't need to know, but is going to be useful when I'm demonstrating stuff to you. This is the cat command. What this essentially lets me do is show you the contents of the file. Right, so here is the contents of hello.txt. So when I type in cat, that's just printing to the screen. Okay, so here I want to go into Python, and this is how we're going to open a file for reading. Right? So file is equal to open. Okay, I don't want to call this file, so I want to emphasize this as a name. Greg, right, is equal to open hello.txt for reading. That's what that R means here. So boom, it's open. So now what I can do is read a line from this. Read a line, read a line. Can anyone explain this behavior? Well, that's the file, right? So when you read from a file, you're always reading a string. You read in one line, that line is coming in as a string, even if it's a sequence of numbers. The string includes the carriage return, right? So what is the first line of this file? It's not what a, it's what a new line. Does that make sense? I see some like puzzlement, right? But that's why Python is pulling out a new line, right? The quotes here are indicating that this is a string, right? So remember, if I take something like this and print it, well, it's going to print a new line, and then Python is going to print another new line. And I can always throw in an arbitrary number of new lines, right? Because the new line is just an instruction to the computer when it's printing, right? Remember, strings, their content, and printing a string are two different things, right? So a string can contain things like tab characters and new lines, right? So don't forget this little nuance. Okay, here's another way that we can read through files. So if I open this file again, oops, that file does not exist, and I just overwrote it, which ruins something later. Open, what is this? What did I create? Hello.txt for reading. Files are iterables, which means that we can use them in for loops. Remember how lists were iterables and range and strings, right? Anything is iterable if I can count through the members of the group. The members of a file are its lines, right? So you could sort of mathematically regard a file as a list of strings, where you can only sort of access each list element once. So because it's iterable, I can say stuff like this. For one line in this file, I have to, of course, use proper syntax. For a line in this, someone is going to die. Oh, I didn't use in. Okay, for line in file, there we go. Print the line. All right, I'm just, yeah, print the line. Okay, so now I'm printing strings, which is why these new line characters have disappeared, because instead of printing the new line character, it just executed the new line character. Also note that the quotes have disappeared, because when you print a string, then it's saying, here it is, I've printed your string. If you have a string as a data type, it includes the quotes to indicate that it's a string and not a name. What would happen if I run this again? Any guesses? That's correct. Nothing will come out. Okay, I'm going to draw another picture. Let's think about this. So recall one of the reasons we're using files is that we may require more space than RAM provides us. So imagine I have a terabyte file. What would be a dumb thing to do when you open a file? You don't want to load its entire contents into the RAM. Right? That's the whole reason we're using files, because it won't fit in here. Okay, so when you create a file, or when you open a file, so here's a file. Let's call this hello.txt, and this has the lines what, new line, a wonderful new line, hello world. Okay. This file is comprised of lines, line 0, line 1, line 2, line 3, and so on. So when I create a file and I open it, hello.txt for reading. Didn't like you anyways. So remember when we created a list, that we're not actually storing the list, but the list is elsewhere in memory and we're getting a pointer to the list? Similar thing with files, with a little bit different. Right? A file is also a pointer, but not only does it point to a file, it points to a specific line of a specific file. Right? So if you open hello.txt for reading, it says, sure, here's your file, and I'm ready to read the first line. As soon as you read, this pointer gets moved. Right? It says, I'm still pointing at the file, I'm ready to read the next line. If you run this 1, 2, 3, 4 times, eventually the pointer is going to be here. And embedded in this file is something called EOF, end of file. Right? So the pointer is pointing at the end of file. It says, I'm ready to read. I say read. It says end of file, nothing. Right? So you can only read these lists in one direction, and you can't go backwards. Well, you can, but I'm not going to teach you how. Because it's more simple at the moment to just see these lists as allowing you access to each line once. Okay, so there's two ways to move your read back to the beginning of the file. The proper way, which is an advanced thing, I'm not supposed to show you this, but anyways. File.seek, you can give it a line number to go back to, okay? I'm going to only allow you to call seek with 0, right? Because what seek with 0 does is return you to the 0 line, which means that I can run this again. Okay? If you want to return. Alternatively, you can open the file again. And that will let you write. Okay? So that's two ways of returning the file pointer to the front of the list again. Everyone savvy? Okay. Slide 5 of 17 and 20 minutes left. It's going to be great. No, we had a good discussion today. I'm happy. Here is the syntax for opening a file. So you have to give the file a name. I called it file, but you can call it anything. Remember, maybe I shouldn't call this file. Many online Python tutorials use the word FP rather than file, which stands for file pointer. Right? Just to remind the user that you're not manipulating a file. You really only have one line of access. So the modes that we can open a file with, there's at least 3 of them. There are actually 8, but these are the 3 that you need to know. So you say file, open, you give it a string for a name. Oh, there's one other thing I had to show you. So if I open a file that doesn't exist, blah, for reading, it's going to say, this doesn't exist. I have to tell you where to put these files so that they're readable, right? So look here. So I have on my desktop here, I have this, what file did I just write? Hello? I have this hello world.txt. And I can go into Python and I can open this file for reading, let's say, okay? If I go to a different part of my computer, right now I'm in my home directory, and I try to call in that file, if I try to read in my hello file, it doesn't exist. It exists on my computer. It just doesn't exist in this directory, right? So when you're opening something, Python is looking in its working directory. Okay, what is your working directory? I'm going to teach you how to find this out, okay? Import operating system. Operating system dot get current working directory. Import os dot get current working directory. There. Right, my current working directory in this shell is home. My current directory here, os dot get current working directory, was desktop. Right, so open your Python, run this command, figure out where your current working directory is, and know that's where you have to dump your files. Alternatively, you can give the full path, I can give the full path to the file, and that will also work. Okay. For those of you on Windows, I hate this about Windows. You have to do this. What? Yeah, you have to escape to get the escape. Right? That's how directories look like in strings in Windows. So just be aware of this. Right? That you have to use double braces. For the life of me, I don't know why. Okay, so that's that nuance. So we can open files for reading. That's easy. Puts the file pointer at the beginning and reads lines. Write. What this will do is create a file and open it for writing. Okay, so there's something very important you need to know here. Where am I? Home. I want to go to desktop. I want to stop being distracted by these other shells. Can we see this? No. Okay. There's the contents of hello.txt. Okay. Now I'm going to go into Python. I'm going to open a file, hello.txt, for writing. I'm going to write to my file my name, and I'm going to then close the file, which I also have to talk about. Really got off track today. Let's exit this. Let's look again at what is the contents of hello. All of the previous information has disappeared. Be very careful when using write. Write will delete the file if it exists and create a new one. And so if you write to something which is important, you're going to lose it. Be sure to make data backups before you start playing with this. The correct way, maybe, to write to a file without destroying it is like this. File, open, hello.txt for appending. Right, now I can write something. And let's see. All right. Now my old information is there, and I've simply put something at the end. Right, so be very careful when using write. You will destroy your data, right, which is not very pleasant when you need it. Yeah, so I actually had slides today, but we went sort of off the book, which is fine. Closing files. So what we're doing basically is telling the computer that I'm going to leave this piece of memory. Can you please allocate me some memory on the hard disk? So the computer says, sure, here's some memory. But the computer doesn't know ahead of time how much memory is going to be used. So it's sort of just waiting around until you finish your computation and give an instruction to close the file, at which point Python inserts this end of file line. Now, what happens if you open a file? Okay, first of all, if you forget to close your file, it's just going to use the next end of line that it can find in memory as the end of your file. Right, so if you do some text processing on a file and forget to close it, you may find two things have happened when you look at your data. First option, there is less data in your file than you expected there to be, right? Because an end of line was inserted too early because you forgot to close. The second thing that may happen is your file has more stuff in it than you expected, and the more stuff looks like garbage, right? What has happened there is basically it's inserted the contents of another file that happened to be in memory, maybe a movie, an MP3, a picture, but that file had an end of line or end of file, right? So it just went all the way to there. So my point is, you need to say file.close in order for the end of file line to be put there. Otherwise, your files are going to look really strange, right? Predictably strange. So be sure to close your files after you use them. There is an so in your homework on Piazza, basically on your test and maybe on your assignments, you're going to be using the file open, file close paradigm. This is actually the more appropriate Pythonic way of doing it. This is what I use, actually. This is what programmers use. This has two benefits. So where's my try-catch friend? I have a question for you. What happens if I'm working with a file, I open it, and then throw an exception, divide by 0 or something? I open a file, and I start processing the file. Suppose I say, I want to take every line of this file, it's an integer, and I want to take 1 divided by the line in the file, right? And suppose one of those numbers is 0, right? So what happens? Well, it's not a trick question, right? So you'll get a division by 0. Okay, so this is where I was trying to get you to. If I'm doing a file process, and during the processing of that file, I divide by 0, say, it throws an exception, the computer will crash. Well, the program will crash, basically. It says, you've thrown an error, I can't continue. Which means that if you put a file.close in your code, it wouldn't have got executed, right? So if you open a file and you've written some faulty code that crashes, the result of that may be you've corrupted the file that you've worked with, right? Because you haven't inserted an end of file. So how can I catch these type of exceptions? With a try catch. Okay, but I hate try catches. This has a built-in try catch, basically, right? So if you open a file like this, this has the benefit of two things. One, everything that's indented is code that is utilizing file I/O, right? So when you're writing code, this makes it, for one, very clear what parts of the code are using file input-output. Second of all, this code block, if it fails, Python will still close the file. Right, so this is better than opening and closing by yourself because the open-close is built into this code block. And even if you throw an exception, it's going to close the file for you. So this is going to insulate you from corrupting files. So I'll just show you how to use that. It doesn't work very well in the interactive mode. This is really only something that you would use when programming. So let me code. What day is it today? Friday? No, geez, wishful thinking. Wednesday. Touch. Where? What? Okay. Okay. So do I have a file on my desktop somewhere? I think I had something called hello that still existed. Yes. Okay. So I can say with open. Actually, let me define a function. I can say something like with open this hello.text for reading as, and you give it a name, Sally, right? Then I can say something like Sally.readline and then return. Blah. Okay, let's print this just so it does something. Cool. It went in and printed the first line and exited. And the file has been closed, right? So when you're coding, I would recommend using this data structure. When you're working interactively, it gets kind of a pain because then you have to like write all of your commands one tab out, which the interactive mode isn't really designed for. Okay, I have two options here. We can write a program to count the number of empty lines in a file, or I can write a program that does some text processing on tab-separated information. Which one would you prefer? Tab-separated information? I think I overwrote my bands file. Yeah, I just have to go grab that. Whoops. Week 6? How many weeks are there in a semester? Anyone know? Anyways, I was just trying to waffle. Anyways, so here's the contents of bands. Whoops. Okay. So this is like a very, these are look more closely to data that's in the wild. We have two types of data really that are typical. TSV, tab separated values, or CSV, comma separated values. Right? So this is what Excel would export basically if you asked it to. Right? So remember that we're computer scientists, we make the rules. Right? So I'm saying if we want to process data like spreadsheet data, let us all agree that one row of the spreadsheet are to be pieces of information separated by commas. Right? That is going to be our assumption working together. And let's assume that one line corresponds to one row of the Excel sheet. It's not the only way to represent an Excel file, but it is one way, and it is the most typical way. Okay, so let's read this in. And how much time do I got? 10 minutes? Okay. So note we're going to have to skip the first 3 lines here, right? Because the first line is a header, the second line is a comment, and the third line is a comment, right? So if I had more time, I'd write some type of, I could write code that said, read the header, and then skip all of the lines beginning with a hat. That shouldn't be too hard. All right, so let's just work with this file. So foo with, I'm on my desktop, so with open bands.txt for reading as, let's just call this file. So I'm going to open this for reading. Okay, so I'm going to show you how I program when I'm not in front of you guys. So I basically just throw in pieces of code and make sure everything's working as I move. Like I don't try to write a whole program and then check if it works. So I'm going to open the file, and to ensure it's open, I'm just going to print everything in it. So for line in my file, just print the file. Right? So let's just check out if that's working or not. Wednesday. I'm not on my desktop. Wednesday. Foo? Oh, I'm printing the file. I have to print a read line. I have to print the line. Okay. Okay. So this code at least succeeds in opening a file, reading lines from the file, and then printing those lines. So what I want to do here, whoops, not here. So my file is open. I want to skip the header. Right? The header is this. The header is this thing, right? So often your comma-separated values has a header which tells you what the values are in each column. So skip the header. I'm just going to read once, file.readLine. Just going to move the file pointer by 1, and I don't care about the contents. I'm going to say for line in file. Right, so I'm going to pull a line out of the file. I'm going to say if the line, if the first member of that line is a hash, then just let's skip, right? Continue. Else, actually I can do this more simply. Right? If this isn't equal to a hash, break. Right? So what I'm trying to do here is just skip all of the lines which are comments. Right? You see there are 2 lines here, right, that don't actually contain data. They're comments. And comments are denoted by starting with hashes. Right? So my program so far skips the first header line, and then it should skip the comment lines. And then let's do another experiment here. Right? So if I start printing from here, I should only be printing lines with data. Lines with data. Okay, so these are all strings. So what do I have to do now? I need to take these strings and I need to separate them by their commas. So this is why it was a good idea to separate by commas, because we can do this now. You should have used this on your last assignment. So I can split the line across commas. And just let me print this. Oops. Okay, so I've skipped the first 3 lines, I've pulled out 1 line, and I've split it across the commas. So what's the problem here? It's not, the escape character doesn't matter that much, because if I integer 1, 2, 3 new line, it still comes out as 1, 2, 3. So the problem is everything got read in as a string. So the numbers are still strings. I need them to be numbers. Right? So I have to go here, and I have to say something like, band is the line first thing. What's the next thing? Geez, what was contained in the header? Rating and plays. Okay, band rating is the thing at 2. Oh, sorry, 1, and plays is the thing at line 2. So let's just print the band, the rating, and the plays. Yeah, there it did it. So it didn't print out very nicely. I should have printed it as a tuple. Okay. But here's a piece of code which goes into this file, right, and actually isolates the pieces of information line by line. What I want you to do is write this again, and I want you to write a piece of code that returns the band name with the largest rating, right, or plays. You pick one, right? I'll put all of this code up online, but this is good practice, right, for reading a file, processing it, and returning it. So just study this example a bit. So, so for you to do this question, write a function that counts the number of empty lines. So just note, okay, the length of this is 1. The length of this is 2. Right, so this is an empty line. Right, this is not an empty line. So you can test for an empty line by checking that the only thing the line contains is a new line. That's empty, despite having a length that's non-zero. Okay, so I want you to do this one. I want you to finish the file that the code that I was just working in. And please start preparing for your exams next week. You cannot crash study for this course. It won't work. Right, so start studying now over the weekend. I have office hours today, and drop in any time to see me if you want. All right, see you guys later.